Okay. Yay, we've reached our final video for ionic compound chemical formulas and naming. And these are our polyatomic ions. These are ions composed of two or more atoms covalently bonded together, yet chemically act like a single atom. What on tarnation does that even mean, Miss Three? Great question. So, there are some polyatomic ions, and this is what we have here. And we see their charges here at the sides. We have plus, negative. We've seen these before. What we haven't seen necessarily is it being two elements together with a charge. Right? We haven't seen that yet, but these do exist, and they exist so often that scientists gave them their own names because they group like this and bond together and give off charges. So again, these work as a single atom, right? Or element. So this would almost be like we've done, Na, right? And that just has that plus one charge, and it's just one. These work that same way. It's almost just like, that's what it means when it's just like one unit, but yet there's two elements. They move as if they're one. They're so close together and love each other so much. They don't want to be separated, and so they just move as one single unit together. Almost like husband and wife. Oh, that's so wonderful. Oh my goodness, I didn't think about it like that. Beautiful. Thank you, Jesus. Okay. All right, let's keep moving. So because of that reason, they have, well, that's one of the reasons. They have their own naming system. And you'll learn a lot more about this later on in chemistry. For this class in particular, you'd be given this table to answer any questions that you'd get given on a test. So, for instance, let's give you an example. Rhiannon, what do you mean? Miss Rhea, what do you mean by that? These numbers kind of scare me, don't know what. All right, your job is just to be able to find these, right? Locate these in a chemical formula. Let's look. What would that look like? We have Na2SO4. All right, so if you wanted some practice in this too, and I already circled all of them, so I'm sorry. You can't. You have your sheet on the back. SO4. When you see 1, 2, 3, when you see 3 elements in a formula, that's a very good indicator that you have a polyatomic ion. If not, that is the indicator you have a polyatomic ion. When you look at that and there's more than 2 elements, just go, I'm dealing with a polyatomic ion. Okay? So now that I know that I'm dealing with polyatomic ion because I have more than 2, it's not binary anymore, it's poly. More than 2, poly. Poly. All right, anyway, keep going. I know that I'm dealing with a polyatomic ion, so I'm going to go to my table. I'm going to find the name, right? This is almost just like a fill-in. So the first thing you need to do is identify, right? If you're doing steps, identify if it is a polyatomic ion. We said we could do this by asking the question, is there more than one, 2 elements bound together? Right? Yes, we are dealing with a polyatomic ion. So here we go. We go to our chart. We see we have SO4 here. So we see SO3, 2 negative charge. SO4, 2 negative charge. Okay, so this is the one that we're looking at, SO4. Okay? And its overall charge, right, that SO4, when it's together, remember it acts as a single It acts as a single element, right? It has that 2 negative. And it bonded with a sodium element. But remember, sodium only has a +1 charge. Remember, so to balance those charges, we need two sodium atoms. That's why there's that 2 subscript there. Remember, this one, it stays together. This charge is for this whole compound inside of this one. So this charge, remember, it acts as a single element. So it goes to this whole entire thing. So just think of this as 1. So it's like chloride, right? It just works as 1. So don't let that confuse you. So it's Na, right? We need 2 of them to satisfy this charge on this molecule, which gives us SO4, which is what we see up here. Na2SO4. Beautiful. All right, so for this, I'm going to go ahead and give the answers on it. Calcium carbonate, ammonium chloride. If you want to pause the video with your worksheets that you have at home, I'm just going to pause the video on this chart and fill it out for yourself. And make sure that you're able, right, to balance those charges on ionic compounds with polyatomic ions. Okay, if not, go back, replay this video again to be able to solve the next ones too. But your answers are here for you, so you can double check your work to make sure that you balance them. If you have any questions, just shoot me an email.